Alright, today I'm going to be making this video for those trying to learn linked lists and not trying to waste hours of their time on videos or pointless coding exercises. Now, to learn linked lists, we need to break it down to the building blocks, which is nodes. Now, what a node is basically a building block to store data. The purpose is to store data and connect other data together. So to show it, let's take a basic node here. We have our value and our next. Our value could be a string or an array or a dictionary. It could be whatever. Our next points to the next node, which is a value and a next as well. That is the whole point here. Without the next, then we're just going to have values without any link. So think of our linked list as a link in a chain. We need the next to point to our next node in the list. Now, to start coding it, I did go ahead and break our files down into 3 different files. You could do it in one singular file, but I feel like separating it will make it easier to learn. Now, to start, we need a class for our node. And then we need to set up our initiator. And then we're going to be passing our value that we want to be in our node. And then we're going to be passing the next, which is going to store the next object in the list. So it should look something like this. And then we're going to be passing our self dot value. And then we're going to do the same thing for our next. So this might look a little confusing here, but the point is that we have self. It's going to be stored in our self, which is going to be a part of that value. And then we're going to be assigning it to these. So this, our value here and next is going to be here and here. It might be a little confusing, but it will make sense later. So now we need some methods to make up our class. So we're going to get our get value function. And we're just going to pass self into that. And all we're going to do is return. Simple as that. We're going to be just returning our value. Then we're going to do the same thing for our next. Perfect. They should look pretty identical. Now, a little more complicated, we're going to be setting our value and our next value. So what we're going to do here is set value. We're going to pass our value and our self. Then we're going to be doing self.value equals value. So we have our main self, a part of the node, and then we're going to be passing what value we want to set it to later. We're going to be doing the same thing for our next. And then we're going to do self.next. Now this alone makes up our node class. One more thing to add is we could add a dunder function, which is just like this. I'll explain that in a second. So the point of this dunder function is to return a string version of our value. Without doing that, it's going to return our memory. Alright, now to make a simple node object, we're just going to assign our node here. And then we're going to just put in like 5, and then we're going to set the next one to none, because we don't know what our next object is going to be. And then we can do temp2 equals node. And then we could just set it to like 20. And then we can set our next value, which is right here, to temp. So now this temp2 is going to be linking to temp. Now we can print our temp2.getValue. So how this works is we call our object, and we're calling the getValue function as well. And then we're wrapping it in the string here, which refers to this dunder function. And then we get 20 back, which is right. Or we could do getNext. Let's try getNext. We get 5. So that's showing we're calling from our temp2 object, and we're trying to get the next, which gets temp, which shows the value of 5. Now knowing what a node is, now we can understand what a linked list is. To understand why they're important, we need to know the difference between like an array and a linked list. For an example, arrays are fixed in size, which is like in low-level memory allocations. So if the array fills up that specific memories section, it will allocate to a new larger spot and copy all of the other elements that were in the array to this new spot of memory. Rather, for a linked list, it grows and shrinks dynamically one node at a time. Now you're probably thinking, is linked lists actually that important? And in certain ways, it is crucial. For a real world example, let's think of it as a music playlist, which is a linked list. Now you can hit our next button or our back button, which will go to a previous song or to the next song. Think of that as the linked list methods. We can go between songs at ease, verse, and array. And we can easily add nodes, as in we can easily add songs within the playlist later. Now to make our linked list class, we're going to start off by importing our node. Also, if you're copying me, make sure that all your Python files are in the same directory or this might not work. Also, when importing, this refers to your file, so it is case sensitive. So make sure if yours is capitalized like mine, it is in the file as well. And this refers to the class, which is also capitalized. Now we can make our linked list. Now, just like our node, we need to set our initiation function, which is just going to be self. Now, once created, we need to be able to store our size of our linked list and where the front or the head of our linked list is. So we're going to do self.size, and we're going to equal that to 0. And now we're going to be able to set our front, and we're going to set that to none for now. Now I'm using front. You can use head or whatever. I like to go with front. Now for the linked list, this is considered your front right here, and this is your nodes coming after. So people can call this your head or front, but this is the starting of your linked list. So like an array, it'd be the 0 index of your array. Now to get the most important method down for the linked list, we're going to start with the insert method. We're going to be passing our self and our index and value. So now we're going to create our node, and we're going to set that to node from our other file, and we're going to be passing the value, and we're going to be setting the next to none for now. Now when inserting a node into a linked list, there's a few things we need to do on our checklist before we just insert it. For example, we need to know if the index that we're getting passed of where we want our node to sit isn't greater than our size of our linked list, because then we're going to get an error. So we will do so this is checking if our index is bigger than the size of our linked list, and if it is, we're going to do a basic print out of range, and then we're going to just do a simple return. Now the other check we need to do is if we passed 0, as in we're trying to change the front of our list, we're going to do a simple else if, And then we're going to simply take our node object that we assigned above. And we're going to do set next. And we're going to set it to the front. And then we're going to take the self.front equals our node object. So this may look a little confusing here, but to put it simply is that we have our node object that we set above, and we're setting its next object to the front of the list. So if the front of the list is assigned to a value, we're going to be basically shifting the list. We'll be basically reassigning what the front of the list is. So to show that, let's just say the front of the list is 4, and we have our next, which points to our next node in the linked list. And then we're trying to put our new node in the beginning. So we're going to put it over here. And let's just say it's 6 that we passed. And then we have our next. That line of code points it to the front of the list. So we're now pointing it to the front of the list. But the front is still assigned to right here. So then the next line of code is us just shifting what the front of the list is, which now shows this as the front of the list. Hopefully that made sense for all you guys. Now after that last check, now we can move to our loop to actually insert it, as in if we need to insert it to the middle of the linked list. So we're going to go else. And we're going to assign I to 0 for our loop. And we're going to do our current node equals self.front. Then we're going to set a previous node equal to self.front as well. So this might look a little confusing here, but once we start making the actual loop, it'll make a little more sense. Then we're going to do while I is less than our index, because we know we're not going to go out now because we checked above. We're going to first take our previous node and we're going to set it to our current node. And then we're going to take our current node and equal to current node dot get next. So we're basically moving one at a time. So we're moving our previous node to our current and then our current to the next, if that makes sense. So we basically keep doing that over and over. So we're going to want to iterate our I. And then once it hits the exact index we need to be at, it's going to go out of the loop. And then we're going to use our node object above, which is node in. And we're going to set its next to our current node. Then we're going to set our previous node set next. And we're going to set that to our node object. So basically, we're wedging this in the middle of two node objects. So let's just say we have our node objects here, right? And we're at here for our current. And then this is our previous, right? We're going in and basically saying, hey, we want our node, which is our new node, to point to this. So great, now this is pointing to this node in the linked list. But right now, we can never find this node. We'll never find it. When going through the loop, we're just going to go one by one and just skip over it. So now we need to reassign the previous node, which is this one right here, to right here. So now, when going through, we're going to go here, then here, and then here. So it looks a little weird, but once I describe the remove method, it should make a little more sense if you're still confused. Now that is all to the insert method. Lastly, we just need to update our size of our list. That's all we do. Now, because we inserted, now our size of our list just increased. Keeping track of that is good when we need to show later how big our list gets. Now onto our remove method. We're going to do remove self, and then our index that we want to remove. Now, off the bat, we also need to check if our index is out of the range of our linked list. So we're going to go if index is greater than our size of our list. We're going to print index out of range. And then we're just going to do a simple return. Now, like before, we need to do one more check, as if our index is 0 and we need to remove the front of our list. So we can do else if. Then we're going to take our self.front and we're going to equal it to self.front get next. And then make sure to include the parentheses. So this may look a little confusing, but to show a little diagram of how it works is we have our nodes, right? And this is our main front node, right? We're taking our self.front and then we're getting our next and then we're assigning that to our front. So now this is our front. Now, if it's not at index 0 for best case scenario, we need to make an else. And just like before, we need to assign I to 0 and then set our current node to self.front. And then take a previous as well, previous node, and set that to self.front. And then we're going to do the same thing as before and set a simple while loop while I is less than index. And then we're going to set our previous node equal to our current node, and our current node to current node dot get next. Make sure to include the parentheses. After that, we're just going to increment I. Once we hit the index that we want to remove, we're going to take our previous node and set its next to current node dot get next. So just like we did here with the front, we're basically just getting our previous node and just skipping over it. So we'll have our list here, right? We're basically taking our previous node right here and setting its next to our current, which is right here, to its get next, which is right here. So we're basically linking it right here. So even though that this node, this current one right here, is still linked to here, it is not retrievable anymore. So it's just out of it. So when going through the list, if we have more objects over here, or nodes, we can easily link them. Let's just say we do have other nodes around here, like over here. It can still easily go through. It's just going to skip over the removed node. It's still there, but it's not retrievable. Now, after all this, we're basically going to set our size to 1 less. One more tip, make sure that your self.size is aligned with our else and not inside a loop or anything like that. Now this makes up the general part of our linked list. Now we need some helper methods, I like to call it. We're going to set up a simple dunder method. And we're going to pass self. This is what we're going to do when we want to print our entire linked list. You can do this in multiple ways, but I like to show it with like arrows to make like a nice little diagram in a way. So I'm going to make a simple string. We're going to set it to nothing at the moment. Then we're going to get our current node. And we're going to set it to the front of the list as such. Then for our while loop, we're going to do while our current node is not none. So if it didn't reach the end or anything, we're going to do if current node does not equal the front, then we're going to do string, and then we're going to add an arrow. I did a space before and after to make it look slightly nicer. And then out of that if block, we're going to take our same string variable and then add to it a string. Then we're going to take our current node, then get value. So we're basically formatting this to a string, adding our current node value as a string. After doing that, we want to set our current node to current node dot get next. Also, again, make sure to include the parentheses. So this alone will loop through the entire list, because at the very end of your list, your last node should not have an assigned next. It should just be none. So once it gets to the end, which is none, it's going to stop. And then out of the while loop, we're going to return our string. That's basically how we return our linked list as a whole. Now let's just say for our linked list, one of the important methods or what makes up a linked list is returning an explicit item or index within the linked list. So to do that, we're going to call getItem. Now you can do this multiple ways, which I'll show you later. But for right now, we're just going to call it getItem, and then we're going to pass self and index in there. Then just like before, we're going to check if index is greater than the size. Then we're going to print index out of range. Then we want to return. That's the only check we need. Now we can move on to our basic loop. We're going to set else. Then we're going to assign I to 0. Then I'm going to call it item equals the front of our list. Then while I does not equal index. Now we want to do item equals item dot get next, and then increment it. So this is going to go through until we hit our index. Once we do, we want to just return it. Item dot get value. Now that makes up our entire getItem method. Now our last method, which can be a dunder method, is going to be our length of our linked list, our size, if you want to call it, which is super easy. We can just go just like that, pass in self, and then we're just going to return self.size. Now that makes up our linked list. Now if we move over to our main.py, once here we need to import our linked list. Now like before, this is our file name. Make sure it is matching our file name, which is case sensitive. Same with our import from our class and the other file. Make sure that matches up as well. Now we can easily make our linked list object by going mylist equals linked list. And then make sure you include the parentheses. Now there is our linked list object. Now we can easily insert it by going mylist.insert, the method we made earlier. We can assign it as our index, which is 0, and then we can pass the value in as 1. Now if we check on our linked list, it is our index first and then our value. Make sure that is correct. So we're going to be putting it in the front of our list. Now let's just say we want to copy that down and we want to put 2 in the front of our list. We can do a simple check to make sure that works as well. And then we can maybe pass in maybe 3, set that as 1, set this to 2 or 3. We get the point. All right, now we can print out our list. We're going to do string, and then we're going to pass in our list. Now there's a few ways that we can do this, just like how I mentioned before with our getItem, which I'm going to show you in a small bit here. But we're going to go through and do the rest of our methods that we created, like with mylist.remove. Now we can do, let's just say 2. We're going to remove the index 2. And then we're going to reprint our list. Then let's just say we want to get our item. We're going to go print mylist dot get item. And then we're going to pass in which item. Let's just say 1. And then one more thing is we're going to print the length. Print length and then mylist. Now we can run it. Now as you see that we inserted 1, 2, 3, and 4, then we removed our 4, which does not show here now. Then we can get an item like this, which is our 1, which is our 3, and then our length is 3. Now what I was going to show you about the get item, this is a personal preference, is if we look closely, we have our length here and then my list. We can easily do dot length like that, and then if we go back to our length, we can run it just like that. It's just personal preference how you want to do that. I like to do it like this. Now for get item, this is a cool part. You can make it a dunder method in a way. And instead of doing dot get item, we can just do just like that. So as if we're indexing through an array. So if you prefer it like this, go like that, or do like what I do, which is dot get item. And alright, that wraps it up for this video. Let me know in the comments if you guys like this video and you want it to become like a series for other DSA problems. Other than that, I'll see you guys in the next one.